Now we'll move on to the next portion or main heading or theory portion, which is color coding of resistors. That is, see the real life resistors look like a band, just like the figure which is shown here. So, like as you can see, there are bands of color, right? These bands of colors will be different for different resistors. It is by looking at these bands you can say what is the value of a resistor in a commercial way. That is, suppose a person is giving you a resistor of 12 kilo ohm, you can also find the value whether it is 12 kilo ohm or not by simple calculation or simple comparison of the color with its codes. Clear? So we'll learn how it is done, right? So let's move on. When you see the figure of a resistor or actual resistor, there are four bands as you can see in the figure and the figure which was earlier shown. And there are four bands. I have named it as A, B, C and D. Now this A and B color is for indicating the significant figures. You will understand when I do a numerical along with it, but just understand this portion. A and B band, that is the first and the second band, indicates the significant figures of the value of the resistor. The C part, that is the third band, indicates a multiplier, and the last band is tolerance. We'll deal with tolerance first, then we'll go for this section. What do you mean by tolerance? That is how much toleration or how much is the maximum value or permissible limit of resistor. Right, due to temperature change etc. the resistance value can change, right? So how much change or how much is the maximum change that is tolerated by this resistance is indicated by the D value or the last band, that is tolerance. That is the last color can be only three types, that is it can be either gold or silver, or there will be no color. No color will be mentioned. That is, if the band is or there is only three bands A, B and C, and there is no fourth band, means it indicates no color, right? Suppose you are having a resistor such a way that I am not going to mention the first three. The last band is of gold. So gold's tolerance, if the band is gold, indicates the tolerance is plus or minus 5%. If the last band is silver band, it is plus or minus 10%, and if there is no color, it is plus or minus 20%. That means, guys, if you consider a proper resistance of 22 kilo ohm, you commercially purchase a resistance of 22 kilo ohm, it doesn't mean that its resistance will be always 22 kilo ohm. It can change from slight value. Suppose that 22 kilo ohms resistor is having a tolerance of 5%, that is the last band is gold color. That indicates that its variation, that the resistance value can be 22 plus 5% of 22, or it will be 22 minus 5% of 22, right? It can vary with the value 22 plus value or 22 minus value, or with this layman language, sometimes, that is if you consider 100 ohm resistance, so it can vary between suppose 98 to 102, like that. There is a variation. This much is the limit of that resistance. I hope you understood. So as the band you can see, depending upon that band you can understand whether this tolerance is high or low. So suppose you have low color, 20% indication indicates that its variation is high, right? Variation is high means if you are having the same resistance 22 kilo ohm with the tolerance of plus or minus 20%, means its range is higher. That is, it will be very high range. I can say, suppose what is 20% of 22 kilo ohm? 2 by 10, or it is 44 by 10 or 4.4. So variation is 22 plus 4.4 or 22 minus 4.4. That the variation, the resistance you will get is either 26.4 or it will be less, that is 17.6. Right, this is the much variation, right? That means variation is large, huge, more than 9, I would say, right? The difference is more than 9. So that means its exact value is very less. That is 22 kilo ohm can, if you take a 22 kilo ohm with a tolerance of 20% resistance, its value, actual value can either be between 26.4 and 17.6. So you will never get a proper 22 kilo ohm, right? So that means as much the tolerance increases, that much precision less resistance is, and as much precision less that resistance is, that much cheap it is. So as the tolerance value increases, that much cheap or the costlier value or cost is very less in those days of resistance. This much clear? Right. Now let's move on. How can I understand by looking at the band, or how can I evaluate a resistor value by looking at the bands on it? Right. Suppose I'm going to write a color coding system which you have to by heart. I'll take another sheet paper, we'll go by the other, and here we'll write the examples. Right, so you have to make a table, guys. So this is alphabet, color, value of the band, and the last is multiplier. Right, alphabet is, how would I remember, is B.B. Roy of Great Britain had very good wife. You guys might have learned it, or learned it in the earlier class. We just have to brush it up. This B is for black, this is brown, red, orange, yellow, green, blue, violet, gray, and white. Right, now black's value is 0, brown 1, 2, 3, 4, 5, 6, 7, 8, 9, and the multiplier is 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3, 10 to the power 4, 10 to the power 5, 10 to the power 6, 10 to the power 7, 10 to the power 8, and 10 to the power 9. This much thing you have to by heart. This is very easy. What was a code for remembering this? B.B. Roy of Great Britain had very good wife. Right. Now how we are going to use it for finding the color coding, we'll see that. Suppose this is your resistor, 4 colors. Right. This is, I'm going to write the colors here: blue, black, orange, and the last is gold. Right, so blue, right, so I'll go for blue. What is the first indication? First 2 colors is for significant figures, right? So blue first is 6, black, go for it, it is 0, orange, right, orange is 3, but third one, C, is for multiplier, that is 3 is multiplier is 10 to the power 3, and gold is plus or minus 5%. So the actual value of this resistor is 60 into 10 to the power 3 plus or minus 5%. I hope it is clear. Similarly, we'll do another one. Again, a band like this, 4, it is brown, blue, red, and silver. So for corresponding brown, look into the code, right? Brown starts BB, right? BB Roy. So BB Roy 0, 1. So 1. Blue, right? BB Roy of Great Britain, right? So so B will be 6, right? Then red, which is the color code for it, it is BB Roy. So it is 0, 1, 2. So 2. Right, but the third term is what? A multiplier. So in place of 2 I have to write 10 to the power 2, right? And silver is indicating the tolerance of how much? Plus or minus 10%. So actual value of a resistance which is having a color code like this is 16 into 16 10 square plus or minus 10%. Right, that the range is either 16, there what happens, 16 to 10 squared is 1600, right, plus or minus 10%, or it is what, 1.6 kilo ohm plus or minus 10 percentage, right? So the range can be either 1.6 plus 10 percentage or 1.6 minus 10 percentage value will be the resistance of the given resistor, right? I will do another one also. Suppose the color code is like this: blue, orange, then green, only, right? This is the color code which is given. So blue is having what color code? 6. Then orange is having 3. Third is multiplier, right? So green is having 5, so the multiplier is 10 to power 5. There is no color means it is indication of plus or minus 20 percentage. So what is the actual value of that resistance? 63 into 10 to power 5 plus or minus 20 percentage. This is the actual value of that resistance. I hope this much is clear. Right. Now I'll give you homework regarding the same. You can do a lot of questions. It's very simple to answer this type of questions. It usually asks for 1 mark. Let's move on.